everybody. Thank you for joining us today. Welcome to the meeting number 6 of the Natural Resources Committee. Sorry, we're starting a little bit late. We had some technical challenges, as periodically is the case in our current environment, but nonetheless, we're all good to go here. So thank you for joining us. The last 15 minutes of this meeting, we're going to move to committee business. We're going to address the scheduling of the balance of the study and some other appearances. So just so everybody knows, we can deal with that at the end and focus on our witnesses we have today, which is a total of 5 groups. We have ERS Fuels, Green Nanotechnologies, Vision Biomass, representative from the Department of Natural Resources, and Cooperative Forestière du Petit Paris. So thank you to all of our witnesses for joining us today. The process, so all of you know, will be given up to 5 minutes for each group to make a presentation. After all of the groups have done their presentation, we will open the floor to questions from members of the committee. You are welcome to speak in English or French or both. Interpretation services are available. You should have them on your end. We have them on ours. So thank you very much for joining us today. I'm going to start with ERS. So I don't know if that's Mr. Small or Kazmini. I'll leave it to you, but you have
Good morning.
5 minutes.
Good morning. I assume everyone can hear me?
Loud and clear.
Excellent. Mr. Chair, I am extremely pleased to appear before you and your colleagues here at this virtual sitting of the Standing Committee of Natural Resources. Some background on my business partner, now deceased, and I. Doug was the founder of Bird Tool in the UK and was frequently presented honors for having the first lights out facility in automotive tier 1, was the centerfold of the industry publication, and was visited by the founder of Toyota Motors Manufacturing Corp., Mr. Toyota. His firm was purchased by my employer. Doug and I worked to relocate a large contract from Japan to Canada because Canada had higher quality supplier ratings for the dynamic sealing systems. My employer, Standard Products, was the largest of this product worldwide, and I was engineering lead for the group to accomplish this task on behalf of Ford in St. Thomas. Prior to holding a technical management up to director positions over 30 years in automotive tier 1, I spent 6 years in Florida as engineering manager of an ophthalmic lens manufacturer, where I developed the patented system to injection mold ophthalmic lenses with the prescription already in the lens. I was asked to be the keynote speaker for the Society of Advanced Processes and Materials that year in California. Later, when I returned to Canada, my team invented the single-piece fastener-injected bow seal for Pininfarina, an Italian coach maker for Ferrari, Bentley, and Rolls-Royce. We located manufacturing in Stratford, Ontario. About 5 years ago, we wanted to make a difference and help the planet, and decided that if we could design a solid, renewable, odorless, smokeless, biomass-based fuel as a direct replacement for coal, we could have a huge impact. ERS Fuel was born after meeting our eventual president and financier, Mr. Sam Kazmini. He is a serial entrepreneur with a real soft spot on initiatives that help our environment. We created a team and located our worldwide development center near Stratford, Ontario. All biomass-based competing products share a number of common flaws, which over 2 years we were able to formulate our way clear of. Chief among them is they only produce 5,000 to 7,000 BTUs, while coal is around 12,000. We identified an unwanted part of every landfill in the world that would be chemically correct to use as a binder, and then over another year did a series of tests to manufacture the fuel. The result is a fuel that produces 12,000 BTUs, has little or no emissions, 99.995% combustion efficiency, and the 0.05% ash can be added immediately to agriculture on the soil. We partnered with ICFAR, the Institute for Chemicals and Fuels from Alternative Resources attached to Ontario's Western University, chaired by Dr. Baruti, who was very helpful and became quite enamored of our work. ERS Fuel has developed a patented process and is able to recombine the biomass and binder into a new material, patented, that has a density of 1 and takes the oxygen from the binder, adds it to the oxygen in the biomass, resulting in our fuel having twice as much oxygen as in the air we breathe. ERS Fuel self-supports combustion, producing a clean blue flame. We continue to test different biomass from around the world and validate testing through an independent lab in Toronto. The path was torturous and expensive. Our first fuel puck was 3 minutes manufacturing time. Now, 4 equipment iterations later, it is 3 seconds through automotive-based continuous improvement techniques. As time progressed, we realized the government was espousing green strategies where we could align with them and make it happen in Canada. Of particular interest was off-grid northern and Indigenous communities where the government flies in diesel to keep them running and polluting. Our sales director and I were guests at an Indigenous convention in Calgary, James Cree First Nation, attended by their assembly, and had a booth on the main floor, which was heavily trafficked by many band leaders. The response was overwhelmingly positive, and we set out to develop purpose-built equipment that would replace diesel, provide electricity, heat greenhouses and municipal buildings, and produce solid fuel for off-reserve properties while providing employment for its members. We will establish seats at local colleges to train members of these Indigenous communities in forestry management and small utility operations. We have the technology, we have the team, and the vision. We are only missing the support from our federal government at this time. We need the government to act on their environmental goals, support Canadian innovation, and in that regard, and help us facilitate this move to a cleaner, more sustainable future for our country. Thank you for hearing these comments.
Thank you very much, Mr. Small. Okay, moving over to Dr. Sain. You have 5 minutes, sir. You're still on mute. There you go.
Thank you. All right, Chairman Maloney, I'm very pleased to appear today before you and before your committee. Today, in my capacity as a chief consultant for green nanotechnologies, I will give a brief descriptions of the company and the products, outlets, and the history. Green nanotechnology has been established in 2015, and as a startup company associated with the University of Toronto and Green Nano Management to commercialize the invention on a nanocellulose technology and carbon technology developed by inventors at University of Toronto. Since 2015, Green Nanotechnology has developed 2 facilities, one in Toronto, downtown, close to downtown, and another is in Windsor. The Windsor facility actually has been developed in collaboration with Ford Canada to foster their innovations in lightweight manufacturing using light nanofiber-based composite products. In downtown Toronto, the facility actually involves in nanofiber production, nanofiber-based products and device manufacturing, and also a sales marketing initiatives there for the sectors of care, automotive, and disposable mass packaging. just give a little bit of history of mine as a consultant. I do have a positions at the University of Toronto as a professor and a former dean of faculty of forestry at University of Toronto as well. Being globally presented since 1980, the forest product for value-added applications. I was one of the founder of the World WPC Forum. It is wood fiber plastic composite foams in 1989 at University of Toronto. Since then, in 1993, we actually launched our first company at Toronto, followed by several companies in the United States. Since that time, WPC industry today globally worth about $8 million. We did have in Canada about 21 companies at one stage. That was the peak of the business in Canada, which was about 2005. In 2008, we lost practically all of them, except only 2, which is still existing in the Toronto area. Beyond this, the business all gone to mostly centered in Asia Pacific and China. Last year, China had a market of about $6 billion itself. This shows the potential of the forest product industry for the value-added applications. Since that time, our university ventured into another company known as Green Co Technology, which has been developed as a part of the collaboration with Magna and Ford Motor Company, with involvement of a few other OEMs from Ontario to develop lightweight composite materials for automotive industry. In 2009, we demonstrated that microfiber based from wood pulp can be used and convert form as a structural material, the first time globally as a structural door model in Nissan Sentra GXC. Unfortunately, after 2008, because of the fiberglass market from Chinese pricing, the market at that point of time could not compete price-wise, and therefore we had to move to some more value-added application at that point of time. As a result, in 2015, Green Nanotechnologies has been accepted, and since then it has been working towards value-added applications in the 2 sectors primarily. One is in the automotive sector, where we are looking at mostly very high value applications in the EV powertrain development, where the powertrain components contains battery casing, battery packs, with existing about 40% lightweighting of this material and replacing metal type of material which are being used right now. The one of the interesting invention which happened during this time is at the same time, G&T were able to use nanocellulose in a very small quantity to the level of about 5% in combination with forest-based advanced carbon, nanostructured carbon material, which were actually a catalytically combust residues of forest floor, which gives a nanostructured graphene like of carbon materials, which have been introduced in these automotive structural components for the EV powertrain applications. That actually helped these nanofiber, cellulose nanofiber, to overcome one of the largest demerit of high thermal properties. As a result of these hybrid combinations, Green Nanotechnologies were able to have a product which can withstand as high as 170 degrees Celsius in a continuous basis, which is one of the achievements which has been patented by them and being commercialized. Since COVID came, G&T also got involved in the healthcare sectors, and very recently they have developed their new product on renewable mask, which was in combination with University of Toronto's copper coating technology, where they have developed copper coated renewable fiber technology, which is used as a filter for disposable masking system. They have also products which are gone to the
Dr. Sen, I'm going to have to ask you to wrap up quickly, sir.
Just wait 30 seconds. Disposable March packaging. They are now marketing not only hand disinfection agents, but also marketing in the coffee and other packaging area where they are looking at the leads and the high temperature. With that note, I want to thank the committee, and I will end my session here. Thank you.
Thank you. I jumped the gun on interrupting you there, but I appreciate you wrapping up. Okay, Mr. Arsenault, I believe you're next. And I heard you say you're in Sherbrooke. I used to live in Lennoxville, so hope things are well in that neck of the woods.
Yes, they are. I see Madame Rancourt. Madame Rancourt has joined the committee. Elle va faire la présentation.
She will be making the presentation on our behalf, and I'll be able to answer questions in due course. Sorry about that delay. I had a little bit of a problem with Zoom. So thank you, Mr. Chairman, and thanks members of the committee for inviting us to take time to address the important issue of the economic recovery of the forestry sector. You've already met Mr. Arsenault, who's present with me today as co-spokesperson for Vision Biomass Quebec. Vision Biomass Quebec is a group of about 20 organisations from the cooperative, municipal, business, environmental and rural development sectors. These organisations have chosen to unite with a common objective, that of promoting an exemplary and efficient sector of forest biomass heating in Quebec. We participate in the acquisition and dissemination of knowledge in regards to the use of forest biomass for heat production through communication and awareness-raising activities, and we contribute to structuring the sector by taking part in political representation activities. Together, these organisations draw up a vision for the sector full of promises that can well serve the economic recovery of the country. We've identified a potential for heating conversion of buildings in Quebec outside large urban centres, which could make it possible to replace 400 million litres of fossil fuels energy, recover 1 million metric tonnes of residual forest biomass annually, avoid the emission of 1 million metric tonnes of CO2 equivalent per year, produce 4,000 gigawatts of renewable energy annually, improve Quebec's trade balance to the tune of $225 million, and create 12,500 jobs in the construction phase and 3,600 permanent jobs. These values can be certainly increased if we apply this vision to all of Canada, and even more if we add industrial sectors that could consider conversions, for example, cement and steel plants. Via Vision Biomass Quebec strongly believes that forest biomass is part of the solution to allow economic revival of the forestry sector, since it is a wood product resulting from the recovery of forest residues formerly considered as waste and without value. In the province, forest biomass sector can also help consolidate the forest industry through the permanent jobs created and maintained in regions by the supply chain, including harvesting, transport and processing. It's not just the forestry sector that benefits, since forest biomass also allows reduction in GHG emissions, increased energy autonomy and a reduction in the costs of heating buildings. As a renewable and local energy option, available almost everywhere in Canada, but particularly in Quebec, the sector also has an impact on gross domestic product, as well as on provincial and federal government revenues. It can also have a very positive impact on the trade balance of provinces, since the sums spent to produce this energy remain in-house rather than being sent internationally to ensure the supply of fossil products. On the other hand, the sector is not yet mature, and currently most of the market is outside the country. It is essential to develop the internal market because millions of tonnes of forest biomass could be sold locally to create renewable energy and thus contribute to the country's energy transition. A promising avenue for the internal development of the sector can be found in remote communities. Several communities in northern Quebec and British Columbia, Manitoba and Yukon in the Northwest Territories have already converted to using local forest biomass for heating. However, government funding programs are essential for these projects to ensure they are successful and can act as a showcase and thus participate in the healthy development of the sector. Federal programs currently in place to support these conversions should be maintained and could be expanded and enhanced to accelerate conversions and help with economic recovery. In addition, Environmental and Climate Change Canada is in the process of preparing regulations on clean fuels. In this new standard, it is expected that there will be a republication of a standard for liquid products soon and for gaseous and solid products later. The standard provides for the granting of credits for the replacement of liquid products by another liquid of gaseous product with a lower carbon footprint. It will often be a product derived from biomass, but with significant efficiency losses due to its conversion. And the current use of biomass in solid form often involves the displacement of liquid fuel, such as fuel oil, or gaseous fuel, such as propane gas, without significant loss in thermal efficiency. We believe that such displacements should also be eligible for credits. This would support the development of this market in Canada while reducing GHGs accordingly. Currently, it is planned that we will be able to generate credits for the production of renewable natural gas and for the replacement of liquid petroleum products, despite the thermal efficiency losses, but not for the replacement of fuel oil by solid biomass. To promote the biomass sector as well as for the forestry industry in Canada, the Standing Committee on Natural Resources should recommend that the proposed regulation on liquid fuel standards allow credits to be generated for the displacement of any fossil fuels and biomass. The future regulations on solid fuels should do the same. Thank you very much, Mr. Chairman.
Thank you very much. Appreciate that. Right on time. Okay, next we have Mr. Kurtz.
Good morning, Chair. Good morning, committee. I thank you for the opportunity to be appearing as a witness. My name is Werner Kurtz. I'm a senior research scientist with the Canadian Forest Service in Victoria. I lead the team that conducts the greenhouse gas inventories and projections for Canada's forest sector. Today, I want to speak to you about the question of whether the Canadian forest sector recovery and climate change mitigation objectives can be aligned. I have distributed my presentation to the committee. Keeping global mean temperature increases to below 2 degrees centigrade requires net negative emissions in the century. These negative emissions can only be achieved by simultaneously reducing fossil fuel emissions and increasing forest carbon sinks. Globally, at present, forests remove about 30% of human-caused emissions. It is therefore important that when we calculate and estimate mitigation, these must be incremental activities to the existing sinks. Unfortunately, as we witnessed around the world, recently forest sinks are also at risk from climate change, causing large and rapid releases from wildfires. Therefore, developing climate-effective mitigation strategies requires a scientific assessment of the available options. On slide 3, we are fortunate that we have in Canada a forest carbon monitoring, accounting, and reporting system and a series of models. We started developing this carbon budget model in 1989. The third version of it is now used around the world for similar types of analyses. We use these tools to report on past carbon dynamics as legislated for the state of forest reporting and for international reporting. We also conduct project future carbon dynamics, develop climate change mitigation and adaptation strategies, and lay the scientific foundation for various forest carbon initiatives. On slide 4, I show you a picture of 1 million cubic meters of wood. This is containing the amount of equivalent to about 1 million tons of CO2. In British Columbia, we harvest about 67 times this amount. It's about the same amount of CO2 contained in this wood as the emissions from all other sectors in British Columbia. How we use this wood, therefore, matters greatly. And what we have learned, slide 5, in our analyses over the recent years is that there are 2 indicators that we must pay close attention to. The carbon retention time, in other words, the amount of time for which the harvested carbon is retained in the product, and the displacement factor or substitution benefit, in other words, the amount of avoided emissions that we achieve through using a wood product. Bioenergy has a wide range of displacement factors. The highest are achieved if we replace diesel fuel generators in northern communities, but all bioenergy uses have very short carbon retention time, releasing the carbon back into the atmosphere that was removed by tree growth. What we have consistently demonstrated in Canada and around the world is that the highest mitigation benefits are achieved if wood is used in long-lived structural building products that often retain the carbon for decades or centuries. On the next slide, I show you examples of buildings that are constructed in Canada. These are not only high-rises like the 18-story Brock Commons building on campus of University of British Columbia, but also bridges and other infrastructures like hockey rinks and museums. How we use the harvested wood matters. I'll give you a numerical example conducted by my PhD student, Cheng Ji. If we hypothetically were to replace all harvested wood in British Columbia and use it to produce liquid transportation fuels, we could just meet BC's annual demand of about 9 billion litres per year. If, on the other hand, we would, again, hypothetically use all the wood harvested in British Columbia to produce mass timber buildings, we could build around 10,000 of these 18-story Brock Commons buildings per year. But the big difference is that if we used the wood for mass timber, the cumulative emissions by 2050 would be nearly 2 billion tons of CO2 lower with the mass timber approach, because carbon is retained in the wood and emissions from other products are reduced. The same is, of course, also true for fossil fuel emissions, but we release all the carbon from the harvested wood back into the atmosphere. Of course, not all harvested wood can end up in mass timber, and BC does not build 10,000 Brock Commons buildings per year, but this is to demonstrate that how we use the wood matters. There is this problem of climate change and the impacts of wildfires on carbon retention. In British Columbia, the 2017 and 18 wildfires have caused 200 million tons of CO2 emissions per year. That is about 3 times the emissions from all other sectors in British Columbia combined per year. We have therefore recently started a new research project funded by the Pacific Institute for Climate Solutions, in which we address the question of how we can reduce future wildfire emissions and strengthen BC's forest-based bioeconomy at the same time, for example, by using wood residues from fuel treatments in various applications. So in conclusion, keeping temperature increases to below 2 degrees centigrade requires net negative emissions before 2100. And while this may seem far away, this is within the lifetime of children born today. This requires drastic reductions of emissions in all sectors, but it is not achievable with also greatly increasing future forest carbon sinks. These are unfortunately also at risk from climate change, and we need to take the interaction between forest management decisions and fire risk into consideration. Climate effective mitigation strategies in the forest sector exist and must be based on sound scientific assessments of their greenhouse gas impacts. Canada's forest sector recovery can be aligned with climate mitigation objectives through improved forest management, and in particular, the increased use of long-lived wood products. Thank you very much.
Thank you very much, Mr. Kurtz. Okay, last but not least, Mr. Paradis.
Merci beaucoup.
Thank you very much. To begin with, Mr. Chairman, I'd like to thank you for giving me the opportunity to testify before your committee, and hello to the committee members. First, I'd like to introduce myself. I'm from the Coopérative Forestière de Petit Paris. We are Quebecers, we're not Parisians, and we are located in Saguenay-Lac-Saint-Jean, in the beautiful region of Lac-Saint-Jean. We are a forestry cooperative of workers. In other words, all the workers from the cooperative are owners of the cooperative. We've been in existence for 50 years, so you'll understand that an enterprise such as ours, we're an SME, we're not a multinational, but the forestry sector is something that's very important to our company and also to folks who live in our beautiful region. There are about 300 workers that work for the cooperative, and we do all the work in the forestry sector in that area. We also have a sawmill factory, which is a SME, which is one of the biggest independent sawmills in Quebec, in resinous softwood. Now, I'd like to focus on 2 issues today with the current backdrop, and that is that given COVID, our financial situation is not only tough, but in some ways precarious, especially in relation to what we had in the past. And I'd also like to take a look at how important the forestry sector recovery is, how it's fundamental, but also when it comes to regional economics and climate change. Now, if you look at how the sector is coping currently, well, the softwood lumber market is very unstable. The last couple of years have been rather catastrophic for our industries, those that hadn't modernised previously and are having a lot of difficulty getting through this crisis. And the pandemic gave us a bit of a kickstart, but that was only ephemeral and short-lived. And we are highly dependent of regarding what's happening in the United States, and that must be borne in mind. We have been flagging for a couple of months now, and we're very worried about what's going to happen with the market as we continue to languish. Second point, when it comes to the imbalance in terms of sustainable development, there's a strong environmental pressure being placed on all of our economic activities. Of course, it's important to strike a balance between economics and the environment, but in Quebec, there is a huge push to protect the surface area of protected trees. Of course, we want to meet the objectives that the government has set, but there are a whole host of pressures, including endangered species and other issues that limit what we do in the forests, and the number of cubic meters that are able to be harvested has dropped on an annual basis quite significantly over the past 10 years. Then there's the other issue, and that is that the regulatory framework is not well adapted or tailored to our sector, and we've had to be very agile and nimble in order to adapt, kind of on the hop, if you will. So the regulatory framework makes things very tough for us. We've called on an overhaul of the regulatory system for the forestries, which wasn't up to snuff in our opinion. We need more financial and stimulus support. We need programs to support our industry. For example, at a federal level, there's a program that was put in place for the further development of the sector. Now, 80% of the funds of this project went to BC. And in Quebec, we have 30% of the forestry sector jobs. So there's something wrong there. There needs to be a bit more equality in that respect. We need the federal government's support so that we can play our fully fledged role in the sector. Now, if we turn to the future and the strategies that we need to ensure the sustainability of the forestry sector. First, we need to mitigate climate change, of course, and promote adaptation techniques. The forestry sector is absolutely crucial in order to fight climate change. Carbon sequestration, when we pollute nature and it is no longer able itself to sequester carbon, well, then we rely on the forestry sector. We need to focus on the use of wood and timber in all the construction sector. And we need to be able to use this renewable material that has a low carbon footprint on the environment. We need to promote innovation, both in terms of commodities, 2x4s. We need to remain competitive in terms of value added in new markets as well. We need to make sure that the regulation is better customized. Of course, we need to strike a balance between the environment, social aspects, and economics. And we're struggling to maintain that balance, but we're seeing that it's tilting in the favour of the environment more so than economics. Now, we need an economic kickstart and stimulus in our sector. There are 250 municipalities that rely on the forestry sector in Quebec, and we need to be able to safeguard them. Short of doing that, well, will no longer be able to retain and attract labour, and we're already facing a labour shortage in that region. We need to reverse that trend and go further, otherwise there'll be an exodus and we'll see the demise of the forestry sector, and it will not help in terms of regional development. Our forestry sector is crucial, as I said, to fight climate change. And I think that we need to...
But very quickly, please.
Okay. Pas de problème.
No worries. So, in closing, Mr. Chairman, the forestry sector has contributed to economic development in Quebec in a fulsome manner with hydroelectricity, and we need to ensure that we are able to continue in our sustainable development in our sector. Thank you, Mr. Chairman.
Thank you, sir, and apologies for the interruption, but we have to move on. Okay, Mr. Zimmer, I believe you're starting us off this morning.
Yeah, good day, everybody. I'd like to follow up with the notice of motion. I'd like to move the motion this morning, the one that was brought forward last week, that the Honorable Mary Ng, Minister of Small Business, Export Promotion and International Trade, be invited to appear before the committee as part of its ongoing study on economic recovery in the forestry sector prior to December 11th, 2020, to provide critical information relating to the recent WTO ruling, as the government official who appeared on October 30th, 2020 was not able to respond to the question and suggested that Global Affairs Canada appear and answer that question at a future meeting.
All right, thanks, Mr. Zimmer. I know we've got some people who want to speak to this. Would you consider deferring this until the end of the meeting when we're in committee business?
Well, I'd like to just get it over with now in public, if that's possible.
Okay, all right. Well, Mr. Sidhu, you're up next then.
Thank you, Mr. Chair, and thank you to my colleague for bringing this to our attention. I think, as I said last time, it's important that we also hear from GAC officials to hear more about the technical aspect. And I would rather do this near the end of our meeting because I know our witnesses are here, and I don't want to take up more of their precious time. I really want to ask them questions that relate to our study. So that's kind of my suggestions here.
Yeah, and as we said before, the GAC officials are more than welcome to appear with the minister. So it shouldn't be an issue.
Okay, Mr. Lefebvre's got his hand up. If you want to raise your hand, I would ask people to do it in the hands up column on the side, but Mr. Lefebvre, you're next.
Thank you, Mr. Chair. Listen, I think we're pretty much on the same page. We all want the minister to appear. There's no doubt about that. And I think we certainly want to hear from officials as well. We have 4 meetings in front of us, and one of which I believe we're going to try to really get in Minister O'Regan, right, to talk about to appear as well. So that's basically 2 meetings. So that leaves us 2. Again, we could always, the best thing we do, and I'm sure Zimmer has a lot of experience in this, is certainly request when she is available, if she is available in the next in the 4 meetings, the 4 time slots that we have, and then I think take it from there. So I think I'm not opposed at all to the request. Best we could do is ask, and if she can make it in the next 4 meetings, and certainly in the new year. So again, I don't think it's a question of if, it's a question of when that she does appear. So I know on that basis, I don't know if Mr. Zimmer wants to reply to that, and we can get going with the witnesses.
Yeah, and my apologies for taking long. No, I think it's relevant to the forest recovery, the exact topic that's before us in committee. And I think WTO, the ruling, it could be argued, I would say, is the biggest issue really impacting our forest sector, especially in British Columbia, and I know across the country. So I would argue that it's right at the top, and I think it validates the reason why the Minister Ng needs to be here. So.
All right, thanks, Mr. Zimmer. I've got Mr. Cannings and then Mr. McLean.
Yeah, I would just say I think it sounds like we're all on the same page, and I want to hear the witnesses, or I want to question the witnesses. Yeah. So I would just call the question if we can.
Sure. I'm game.
Okay, do we want, Mr. McLean, you've had your hand up, but I'm assuming,
I think the question's been called, Mr.
Yeah,
Chair, so
yeah,
I'm not sure
okay.
I have the floor.
You don't, I just wanted to highlight the fact that you had your hand up. Okay, but thank you. All right, Madam Clerk, do we want to have a recorded vote on this?
Yes.
Sure. So, voting on the question, Ms. Jones? Ms. Jones, are you there? You're muted.
There she is.
Sorry, I can't hear you. Did she give a thumbs up? I didn't see. Miss Jones, would
Can
you
you
be?
You hear me now?
Yes.
Yep.
Okay. Thank you. My apologies for all the technical difficulties this morning, but
Not a
it's
worries.
while.
And so on the motion, Miss Jones, how
Can
would
I make
you?
a suggestion?
What's that, Mr. Maloney?
Why don't you move on to the next person, and then we can go back to Ms. Jones while she's trying to get her
Sure.
audio sorted out.
Mr. Lefebvre?
En faveur.
In favor.
Okay.
In favor.
Mr. Sidhu?
In favor.
Mr. Weiler?
Supports.
Ms. Harder?
I vote in favor.
Mr. McLean?
Je vote pour la motion.
I'm in favor of the motion.
Mr. Patzer?
Yes.
Mr. Zimmer?
I vote in favor.
Monsieur Lemieux?
Je vote pour la motion.
Merci.
In favor of the motion.
Mr. Cannings?
In favor.
And then Ms. Jones?
Oh, I voted yes.
Yes? Oh, sorry. Thank you.
Yes.
All right, then the motion passes, 11 in favor, 0 against.
Decisiveness, that's what we like to see. Okay. All right, thanks, Mr. Zimmer. All right, do you have some questions for our witnesses?
Yeah, I do. I'll, whatever time I have left. Thanks, everybody, for that. Much appreciated. You have a question for Mr. Werner. It's just about, I had a question for Mr. Nyber the last time that we were here in committee, but asking in terms of where are we at in Canada? I know a lot of Canadians see a lot of trees. I know I fly over the country quite often and I see all the forests beneath us. And the question always comes to mind is where are we at in terms of what we produce in terms of carbon wise versus what we sequester or sink naturally. Do you have a number for that? But where do we stand in Canada in terms of just our own geographical footprint?
The internationally reported estimate of carbon emissions of the anthropogenic component, that's the human-caused component of emissions and removals in the managed forest, that is the area for which we have reporting obligations. In 2018, there was a source of 14 megatons. The important aspect here is that in addition, we have large emissions from forest fires, which are in the natural disturbance component of the internationally reported emissions. And we have an unknown contribution of 118 million hectares of northern forests that are not managed, that are outside the reporting obligations, and which are for which we currently have no estimates.
And thank you for that, Mr. Kurt. So what I'm asking for is what we totally produce as a country, as a nation, in terms of carbon output, and in comparative to what our forest actually brings in and sinks. So, and you said 14 megatons. Now, does that does that mean that we produce 14 megatons more than we sink?
We have to keep the numbers in perspective. The emissions from all other sectors are in the order of 570 million tons of CO2. The contribution of forests at the moment is small compared to that. And the climate change impacts on forests from wildfires are very large and have been increasing in recent years.
Okay, so one last question. I know my time is very tight. The one thing that I see quite often, and as a fellow British Columbian, I drive around our forest quite a bit, and what I've noticed a lot is we used to see a lot of the red trees and, you know, the beetle kill, the pine beetle kill, but now we're seeing a lot of the yellow, which is the spruce beetle kill. And what my big concern is how do we manage this problem? Because what you just had talked about, I'm concerned about as well, as seeing what's really a good piece of timber that could be utilized in so many ways, so many productive ways that don't end up into the atmosphere. How do we manage those forests? I know our colleagues to the south in the US, when I knew the Secretary of the Interior, Ryan Zinke, they were managing their forests to really reduce forest fires. And I just one last comment, I guess, you know, how do you do that, I guess, from your perspective? Because to me, and maybe I'll ask it to you this way in just a simple number. What is the contribution towards our megaton total in wildfires every year in Canada?
It varies tremendously between years. We have years like 2020 where we had very little forest fires across Canada. And we had years like 2017 and 18 where we had very large area. And the difference between...
What's a number, just because the 570 sticks out? What's sort of an average?
In extreme years, forest fire emissions can exceed half of that value, 250 million tons of CO2 equivalent.
So managing our forests
all right,
could
thanks.
potentially...
I'm going to have to stop you there,
okay.
Mr. Zimmer.
Yeah, thank you, everybody.
All right.
Thanks, Mr. Kurtz.
Mr. Weiler.
Thank you, Mr. Chair, and I'd also like to thank all the witnesses for joining our meeting today. And I would like to pick up on some of the questions that my colleague, Mr. Zimmer, was asking of Mr. Kurtz. And I think one of the really important aspects that I think it's important that we have clarity on here is about the rate of carbon capture and storage of trees. And Mr. Kurtz, my question to you is, in my understanding, trees begin to capture more carbon as they get older. And so I was wondering if you could speak to what age of trees or forests generally they need to be at before they start rapidly increasing the amount of carbon they store, and what type of implications this should have in terms of the types of forest we should seek to both harvest and or protect.
Yeah, this is a very complex question, and I will try to answer it very briefly. First of all, the carbon uptake, the rate of carbon uptake of a forest stand increases with its age. It peaks depending on which part of the country you're in, between say 50 and 150 years of age. On the west coast of British Columbia, that peak could be later. In the foothills of Alberta, it will be earlier. So basically, the age of a forest determines the rate of carbon uptake as well as the region where it grows, because it determines the overall growth rate and the maximum amount of biomass a forest can retain.
Great. Well, thank you for that. And just for my next question, I was hoping you could describe in a little bit more detail this new National Forest Carbon Monitoring, Accounting, and Reporting System, and I was hoping you could describe how this can better account for GHG emissions from harvested wood products.
So the system has been in operation since 2006 by Canada to report to the United Nations Framework Convention. We generate the numbers and we transfer them to Environment and Climate Change Canada, who combine them with all other sectors. What the system does is it combines computer models with measurements from the ground with remote sensing data on the area affected by fire and insects, harvesting, etc. And we combine all that to estimate the net carbon uptake, the net balance of emissions and removals.
And thank you for that. And you mentioned that there's a number of different ways that this is measured, both from the ground and I assume from aerial views or from satellites as well. I was hoping you could just speak a little bit more to that.
Yeah, so the challenge is that it is very expensive to measure a plot on the ground and to have them distributed across the country. So in order to get an estimate of the entire area, we basically combine ground measurements with remote sensing from aircraft and from satellites, as well as computer models that help us keep track of the millions of pieces of information that we need to combine to arrive at these estimates. But in principle, what we do is we estimate for every hectare of forest in the managed forest of Canada, its age, its species, its rate of growth, and the impacts that affect its ability to grow, whether that's the spruce beetle or the mountain pine beetle or wildfires or thinning or harvesting. We also track the rate of regrowth, and therefore the carbon balance can be reported and stratified by different sectors. There's one other important aspect, and that is the harvested wood products that we extract from the forests are going into a wide range of uses. And so we also have models that keep track of the carbon storage in harvested wood products, whether that's buildings or bioenergy. And we track the substitution benefits, not for reporting purposes, but for the estimation of alternative mitigation strategies.
Very interesting. And you mentioned that in your supporting presentation in the chart where you compared the different products that can be produced using this. And I'm curious, the one that you mentioned has the greatest potential for capturing and storing carbon for the long term was using wood for in buildings. And I'm just curious whether using wood in this manner would actually capture and sequester carbon for longer than in some forests itself.
That very much depends on the impacts of climate change on the forest in particular. When we compare the situation on the west coast of British Columbia, where forests can grow to several hundred years of age, the building may not store the carbon longer than the forest would. However, as we have just witnessed in Washington, California, Oregon, even those forests are at risk from climate change. So one of the things that we analyze with these tools are the trade-offs and the risks associated with retaining carbon in the forest or harvesting and making use of the carbon. It also differs greatly whether the wood is derived from a stand that was already killed by fire or insects, or from a stand that has the potential to continue to sequester carbon.
Yeah, and I think that's a really important point when you look at the impacts from the mountain pine beetle and other infestations. As related to that, do you think it would be feasible for Canada to report greenhouse gas emissions from wood products only at the time where carbon is actually emitted into the atmosphere, rather than just the time of the harvest?
We actually report exactly that way. Since 2015, Canada, in compliance with the International Reporting Guidelines of the Intergovernmental Panel on Climate Change, reports emissions from harvested wood products where and when they occur. So that means that if we export pallets to Europe, we in Canada must report the emissions associated with the burning of the pellets in Europe. If we export a long-lived wood product to the United States to build a mass timber building, we again need to report when the emissions occur, when that building is torn down or recycled or whatever its fate is in its future.
Thank you, Mr. Weiler. Fortunately, that's all your time. Okay, next is Mr. Lemire for 6 minutes.
Merci, Monsieur le Président.
Thank you, Mr. Chairman. They're very interesting presentations we heard about the development of forestry residue, particularly in Quebec, and natural gas in Western Canada. And we saw the economic and environmental gains that have been costed out. And I'd like to delve further into that. So I'd like to ask a question of Ms. Rancourt and Mr. Arsenault from Vision Biomasse Québec. You said that the biomass can in fact deal with a huge quantity of fossil fuels emissions on an annual basis. So which sector would benefit from a transition to biomass? And how can the development of forest-based biomass help Canada's forest or climate change mitigation efforts? Well, thank you very much for the question. Since I made the presentation, I'll allow my colleague to respond to the question if he would agree to do so. Yes, indeed. Well, as Mr. Kurtz mentioned, and as we mentioned in our analysis, 1 tonne of biomass that replaces fossil fuels reduces greenhouse gas emissions to the tune of approximately 1 tonne. Now, if you'd like to draw a comparison with natural gas, there's about the same quantity of energy in a metric cube of it as in a litre of oil. So for all practical purposes, the figures that I mentioned earlier are identical when it comes to natural gas. There can be an equal displacement when it comes to fuel oils. However, practically speaking, from an economic and regionally economic standpoint, there's no natural gas that's penetrating the heating market in Quebec, and the main focus seems to be on fuel oil. And that holds true elsewhere in Canada. In the Atlantic provinces, there's a huge consumption of fuel oil. In Northern Ontario, the same is true. And that could also be displaced and bring the same benefits. There's another issue that interests me a lot. And I'd like to hear from other folks as well. How can the federal government play a role to help the government, to help the committee and sector to make this transition? Tax credits, what other options are available?
Madame Rancourt, Monsieur Arsenault.
Ms. Rancourt, Mr. Arsenault, would you like to start? I thought the question was for somebody else, but let me take a stab at it. The federal government has programs to develop biomass in remote regions, which are being applied across Canada. And I think that they've known limited success. They've been in place for about 4 or 5 years. And there have been a number of programs that have been, in fact, extended. And I think that instead of that, or in addition to that, those programs should be enhanced so that they have a broader impact, particularly in remote regions, but also in regions that are not remote per se. I know that the federal government has an interest in developing Indigenous communities in remote areas, but other regions of Canada could benefit. I referred earlier to the Maritimes, where there's a high proportion or a high use of fuel oil. And in Quebec, at all times, there's a huge amount of fuel oil that's been burned on an annual basis. And this isn't only just in the remote regions. So I think that the existing program should be enhanced, first and foremost, so that these heating systems are transitioned to biomass. That's the main obstacle to the use of biomass. It has a huge investment cost associated with it. That we need to convert existing heating systems so that they can use biomass. Now, if we're targeting a reduction of 35, 50%, 100% GHG emissions by 2050, we need to change the systems. The heating systems have a lifespan traditionally of about 20 or 30 years, so we need to get a head start. Follow up, Mr. Arsenault. What's your vision? There's a document that was developed in 2017 by the Council of Forestry Ministers, and according to them, Canada has the highest proportionate amount of biomass worldwide. So what are the job opportunities in the forestry sector in terms of biomass and sustainable energy, in your opinion? What are the economic opportunities available? Response. Well, I gave you a couple of examples in our presentation. I think we need to enhance the current programs and we need to make them expand their availability geographically speaking. And we need to ensure that forestry biomass is eligible for the issuance of credits under the Clean Fuel Program, which is being currently put in place by Climate Change Canada, Environment and Climate Change Canada. So under our vision, we believe that there'll be about 12,000 new jobs for the installation of new systems and a further several thousand jobs for maintenance. This would help us to consolidate our forestry sector across the board that is currently having a tough time finding a market for its sawmill residues. The use of bioenergy could ensure the survival of those production units, and Mr. Paradis himself set up a biomass heating system in his facilities, and he...
Be there, sir. I'm sorry.
Mr.
No worries.
For 6 minutes.
Okay, well, thank you to all the witnesses here before us. I wish we had all day to ask questions, but I have apparently 6 minutes. So I'm going to focus my questions on Dr. Kurtz because I've been really waiting to hear from you in this study. I think it's very important testimony. So I'll start by you are saying that mitigation must be incremental, additive to what we've been doing. And you pointed out that it's really important to look at how we use our wood. That makes a big difference. But I'm just wondering if you could talk about how we harvest that wood. What sort of impact might that have? Different harvesting techniques, clear cuts, selective logging, that kind of thing. How much impact does that have, and how does it compare with what we do with the wood?
Again, thank you for the question, Mr. Cannings. The challenge here is that, as with all ecological systems, it really depends. When we manage and harvest wood that was already killed by mountain pine beetle, by spruce beetle, by wildfire, drought, or other calamities, we have a very different impact on the timber and the future carbon balance than if we harvest actively growing forests or old growth forests. Scandinavia, that has much better data than we do in Canada, has an ongoing debate about whether a selection cutting based approach or a clear cutting based approach is superior. Each has its own advantages and disadvantages. I would say the jury is still out on that, and certainly in British Columbia, where and other parts of Canada where root diseases and mistletoe and other problems of existing stands can be perpetuated through partial cutting systems. That needs to be considered as well. How we treat the site also matters. So if we slash burn after harvesting, for example, which is often done as a fuel reduction and fire risk reduction strategy, but again, in British Columbia, that causes some 5 million tons of CO2 emissions per year, and these are clearly avoidable if we had alternative and better uses for that biomass.
Thank you. And you mentioned there's kind of I don't know if you call it a lag time, but a time after harvest where sequestration is negative. I mean, there's more emission than sequestration, as I understand it. And then, say, 20, 30 years later, we get to a point of positive sequestration. If we're trying to get to net zero by 2050, how do we manage that 20, 30-year lag time? Because by the time we're getting those benefits, it's already 2050.
Well, first of all, that lag time is not necessarily that long. It could be as little as 5 to 10 years, depending on the site and the rate of regrowth of forests. But yes, if we fail to regenerate adequately, that lag time could be longer, and it could be as long as 20 years, and in extreme cases, perhaps even 30, and that's clearly not desirable. So a lot depends on how we harvest, what we do with the residue that is there, how quickly we replant and encourage reforestation. But the point is that the alternative of not harvesting is not necessarily enhancing forest carbon sinks either. We recently completed a study with Parks Canada looking at our national parks, the forests and 31 national parks, and we showed that since 1990, these national park forests were not carbon sinks over the cumulative period, particularly in the West, where insects, drought, and wildfire caused carbon losses. So conservation and stopping logging in the world of climate change is not necessarily a solution either. So this is why these kinds of analyses are so critically important, so that we can develop science-based, credible analyses of the alternatives that are available to us.
Okay, thank you. Now I just want to move to biofuels such as wood pellets, renewable natural gas that's being proposed in a couple of places in my riding. Yeah, you mentioned that, the disadvantage there is that we are releasing that carbon very quickly, but if we are replacing, there's the replacement or what you're substituting, the substitution benefits. So, up in Mr. Zimmer's riding and every other parts in northern BC, there's a lot of wood pellet production that's being shipped to Europe to get countries like the UK off coal. Is there, I guess, any advice or direction you would give to us with regards to our climate accountability, our climate emissions, as to, again, what kind of forest products we use for those pellets and how they're harvested or something, just to maximize our benefits?
Yep.
Rather than, producing 2x4s?
Yeah, I think, and colleagues and my team, colleagues in British Columbia and my team are all collaborating at the present on various approaches to maximizing not only the value, but also the employment and the climate change mitigation benefits of alternative uses of wood and biomass. If we harvest green trees to turn them into pellets, not only is this economically not a good idea, from a greenhouse gas emissions perspective, it is also not a good idea. If, on the other hand, we use wood that is in a slash pile, and appropriately in a slash pile, and convert that into pellets, because that wood would have been burned anyway, we must recognize that we have a mitigation opportunity by using the energy in the pellet instead of releasing it into the atmosphere. However, where we use the pellets also matters. If we ship them to Europe, we are accountable for the emissions. The Europeans have the benefits of the use of the pellets. Conversely, if we can use the pellets or the biofuels or the renewable gas in Canada to address our own greenhouse gas emission objectives, we have a better outcome. But let me remind you that biomass for bioenergy is typically the lowest value generating opportunity. There are many innovative bioproducts, long-lived wood products that through innovation we need to explore further. Burning the wood as fuel or as a substitute for heat is a low value, low mitigation benefit.
Thank you, Mr. Kurtz.
Thank you.
Apologies for interrupting. Thanks, Mr. Cannings. Okay, we're now moving into second round for 5 minutes each. Mr. McLean, you're starting.
Thank you, Mr. Chair, and thank you to all the witnesses. I'm going to be quick today, so I'm going to ask a handful of questions here, and I've only got 5 minutes. So if I could just quickly ask them each in order. First question to Madame Rancourt and Monsieur Arsenault at Biomass Quebec. You talk about the environmental effects of burning biomass versus gas or liquids. My science background indicated that the most residue comes from solid burning as opposed to gases or liquids. So I'm wondering how this mitigates the GHG, the greenhouse gas, and other pollution effects associated with hydrocarbons, if you could, please.
Well, there is a difference between solid and liquid and gaseous fuels, but it's at the margin. Solid fossil fuel has 94 or 95% carbon content. Oil has 90 or 92, and gas has 85 or 87. They're still very high carbon fuels. And yes, there is a small reduction depending on which fuel you use, but biomass can move all of these energies and reduce greenhouse gases.
Okay, you talked about a 20 to 30 year investment for conversion of systems. Do you recognize that the conversion itself will have massive CO2 emissions associated with the build out?
Massive is probably not the right term. Yes, there are investment required in equipment and installations, but a typical home will generate probably 10 tons of CO2 emissions if it's burning fossil fuel per year. Over 30 years, that's 300 tons. A conversion, even taking into account the greenhouse gases involved with the equipment, is not close to that range at all.
Okay, thank you very much. Much appreciated. I'm going to move to Mr. Kurz now. Mr. Kurz, you talked about the issue around slash burning. What percentage of a harvested tree goes towards the final wood product, and what part is actually slashed, if you will?
So when we refer to slash burning, what we're talking about are the branches, the tops, and broken pieces of wood that stay behind. I would estimate that depending on the area in which we harvest, that is going to be between 5 and 25% of the carbon in the above ground biomass that is not removed from the site. The remainder goes into the harvested wood product sector. And then again, depending on what it is we produce from it, we must discount the bark. That is often carbon in the bark that is often used as hog fuels or other energy source. And then of the remainder, again, depending on the product, 40 to 50% ends up in long-lived wood products, and then the remainder often goes into pulp or bioenergy. And these are all very round numbers because it really depends by sector.
Yeah, sure. So just a range again of which ones are going to be used for fuel. In the process, if you will, of burning the biomass in order to power the operations, which percentage do you think would be in the burn off versus which is sequestered in the final product?
Again, depending on what the product is, I would say between 30 and 40%, sometimes 50% of what is harvested ends up in the final product. Remembering that some of these products themselves can be short-lived, right? If the final product is cardboard, for example, for packaging, it's still a short-lived product.
Okay. And I'm going to move now to, and thank you, by the way, Mr. Kurz. I'm going to move now to ERS. Mr. Small, thank you very much for your presentation. I really appreciate it. Thank you. The detail you gave on the 5,000 BTUs versus 12,000 BTUs for their carbon products. I'd really want to hear more about how your innovation and what it costs, on a user basis to get your product up to the 12,000 BTUs that would normally be part of a normal Earth-produced carbon product.
Thank you. I'm going to answer you in terms of cost per gigajoules because that's the worldwide reference. I'm going to answer two ways. Our system allows the user to produce our fuel for approximately $60 Canadian a ton. What that means is that the cost per gigajoule is something like $1.60. So if I compare that to, for example, gasoline, where it's $28 a gigajoule, you can appreciate that our gas isn't that inexpensive after all. The magic here is we found a way to take what we call a binder that is available in every landfill worldwide, and I'm going to use the evil word plastic, LLDPE. There are 3 trillion, that's with a T, there are 3 trillion shopping bags, garbage bags thrown away per year. We found a way to combine LLDPE with biomass, it can be any kind of biomass, and produce a fuel that's 12,000 BTUs.
Thank you, Mr. Smalling. I'm going to have to cut you off, unfortunately, and move on to. Thank you, Mr. McLean. Mr. Sidhu, over to you for 5 minutes.
Thank you, Mr. Chair, and thank you to all of our witnesses, Mr. Small, Dr. Sain, Ms. Rancour, Mr. Arsenault, Mr. Paradis, and Mr. Kurtz, for being here. My question is for Dr. Sain. I know you're in my neck of the woods. You're here close to Vaughan. Your company does interesting work in finding new applications for wood pulp. The funding you received from NRCan, $1.2 million under the Investments in Forest Industry Transformation Program, is to scale up production of a composite material that can be used in auto manufacturing. Can you share more about how this works? What types of products can you create for cars?
Right. Thank you for having me here. So the way it works is we use wood pulp and forest residue. And we have two different processes. One is a chemical pretreatment and a enzymatic pretreatment, depending on the application, which allows us to reduce the amount of energy we need in order for us to produce from wood pulp to nanofibers, which is normally it's a very energy intensive process. Because of the pretreatment, it reduces. Second thing is, once you have this, the most challenging area of the technology which we have developed is to how to disperse these, very nano small scale fibers into a recycled plastics material, which is coming from some of the waste resources like recycled polyamides. Normally, what will happen is polyamides is a high temperature polymer for the automotive industry. Therefore, this kind of materials like biofiber usually tend to burn. However, because of our pretreatment process, we found extraordinary improvement in the heat resistant property of these nanofibers, and also our in situ defibrillation, which is a very surface energy based process, allows us to disperse it very uniformly in one single step and make the product highly performance comparable to glass fibers. So that's how this material is being made, and therefore these compounds are now valid to use for some of the applications like EV battery and battery casings, battery packs.
Got you. Thank you, Dr. Sen. And do you have any estimates on how this technology and the products you create can help reduce GHG emissions?
Definitely. So there are three aspects. One is, first one is automotive industry mostly using, metals in most cases are very high density composites. So by doing this, we can reduce the weight of the parts by about 50%, and that gives about 10 metric ton, per vehicle type of thing in its lifetime. So if you look at 50,000 vehicles for a single time, it will be about 50 times about 5 metric tons, which can give only a single part. Now we are expecting about 20% replacement in next 7 to 8 years time. So that would be a significant impact for the transportation industry. Second thing is also because it is replacing fiberglass and plastics. Therefore, the additional greenhouse gas reduction from those particular industries' emissions. So that's the second thing. Third important component also, because it is storing biofiber in the car and is recyclable, therefore we have a carbon storage value as well. So these are three aspects we can get out of it.
That's great to hear. And following the completion of the new production facilities, what's next for your technology? Do you see other opportunities to expand?
Right. So we are looking at smart material right now. We have a carbon technology where we are generating, our next product, which is self-generating power-based mask, which means that if you cough, it will generate automotive energy, and that energy can be translated and give a sensing. So this is one of the unique product which is known as nano generators. And this kind of product is because the field biomass carbon can be transformed by catalytic way to a nanostructure. We can generate powers just from the sound or from some sort of vibration. So these are some of the examples, and we are also advancing our technology towards giving applications in the area of smart packaging and also bioprinting. Bioprinting is a scaffold, nanocellulose, and this biomass will be used for in situ scaffolding for remote sensing operation systems. So those are the three new technology we are looking forward, and I think biomanufacturing will be the base and the fundamentals of the next generations of the forest product industry.
Thank you, Mr. Sudhir. I'll have to stop you there. Appreciate it. Okay, Mr. Samard, you have 2.5 minutes.
Merci, Monsieur.
Thank you very much, Mr. Chairman. Very quickly, if I may, I'm sorry I wasn't able to be there earlier. A quick question for Mr. Paradis, if I might. Alain, I visited a private forestry facility, and you really have to be in love with this kind of thing to know about this, and to be interested in it. But I discussed issues with the forestry production representative Daniel Filion and Paul Maurice, and they said that a kind of income averaging system might be useful for the forestry sector, such that the revenue could be divvied up in that manner on an occasional basis. Would you have any input vis-a-vis what I've just proposed? Response: yes, when it comes to the private forestry sector, there are huge needs in that respect. In the public sphere, there's not so much a huge need. But private forestry has huge potential and is really crucial. Now, as far as an income averaging system is referred, well, yes, the idea is to ensure that the industry will be able to buy that wood at the end of the day, so that mechanisms can be put in place to provide for the stable supply for forest sector workers. Yes, that would be useful. Follow-up question. In your presentation, you talked about the interminable conflict that has dragged on with the United States. And I had discussions in the recent months with folks from the forestry sector, and I was told that one of the main irritants is access to liquidity. Throughout the whole crisis period, the federal government's cash liquidity program was such that you had to be, technically speaking, almost on the verge of bankruptcy to be eligible. Have you experienced the same problem? Response: the last couple of years have been catastrophic for our companies. You know, when the market doesn't give you enough revenue vis-a-vis your production costs, and I can tell you that it's the cost of the wood fiber that's shot through the roof, so that makes things even more difficult. So if you're not able to...
Mr. Parody, my apologies. Mr. Canning's over to you for 2.5 minutes.
Well, thank you again, and I'm going to turn back to Dr. Kurtz and just thank you again for highlighting the value of long-lived wood products like engineered wood, mass timber construction. I have a private member's bill that I started in the last Parliament, it's now in the Senate, coming back this way, that promotes the use of wood, especially mass timber construction, simply by highlighting those greenhouse gas sequestration benefits you mentioned. And whenever I promote this online or anywhere, I get pushback from my friends in the cement sector who say that cement is better than wood because it's longer lived, and they claim that the forest industry doesn't take into account all the negative emissions through harvest, through a life cycle analysis. And I just wondered how you would answer that criticism. Does your model take into account the full life cycle, the full emissions involved in harvesting wood and the life of that wood, and how does that compare to cement?
Yes, thank you for the question. I'm very familiar with the study that you are referring to. It does indeed include a number of assumptions and errors that are incorrect. Our model does track the carbon and the impacts of harvesting, including the impacts on dead organic matter pools in the litter wood products litter forest floor and in the soil, as well as in harvested wood products. There are limitations to the spatial resolution of the kinds of models that we use to apply to all of Canada. We're currently working on that to go to much higher spatial resolution and spatially explicit approaches. The specific concern that the industry has expressed is with regard to inadequate regeneration on roads and landings, and they have shown examples of that. This is clearly something that we need to address, but we have also already done analysis of the potential impact of that, and it is much, much smaller than is suggested by the report. Having said that, it is clear that the cement industry will also undertake efforts to improve its carbon footprint. And so as all sectors evolve towards more competitive greenhouse gas strategies, the substitution benefits and displacement factors that we use in our models need to improve over time as the other sectors become more competitive as well. So these are areas of ongoing research, but it's incorrect to claim that we're not accounting for these various issues.
Thank you, Mr. Kurtz, and thank you, Mr. Cannings. Over to you, Mr. Patzer, for 5 minutes.
Thank you very much. Mr. Kurtz, I'm going to stay with you. Earlier, you said that the Scandinavians have better data on climate change. Just wondering, and on their managed forests, wondering why is that? Why is their data better than ours?
It's a simple question of population density. If you look at the size of Scandinavian countries and their population density, they have roads to just about anywhere, and you can pretty much access any piece of boreal forest in Scandinavia relatively easily. In Canada, in contrast, we have huge expenses by using helicopters to approach and measure plots that are in distant locations. So it's simply a question of population density and resources available to do these kinds of inventories. That is one reason why we invest heavily and continue to explore ways to improve our remote sensing satellite-based approaches so that we can use data over larger geographic areas with finer spatial resolution to conduct these kinds of analyses and demonstrate how Canada's forest management is sustainable, what the impacts of climate change are, how fast forests recover from harvesting and wildfires, etc.
Okay, thank you. When you mentioned 200 megatons for forest fires, there, was in your slide deck. It says that's from 2017 and 2018. Do you have a year-by-year set of data that would tell us what the national number is? I think that was just from British Columbia too, from your report. Am I correct?
Yes, so it was just in the context of this particular slide that I used to highlight the impacts of the fires of 2017 and 18. Our system that I described earlier very briefly calculates the emissions from wildfires from 1990 onward in an annual basis for all of the managed forests, broken down by region in the country. The Canadian Forest Service also maintains estimates of area burned in the north, for which we don't have as good emissions estimates, but we're working on that. And we also have estimates of area burned further back into the 50s. When the further back you go, the poorer the quality of data. Of course, there were no satellites at that time. So all in all, to say, yes, we have the tools and the technology to provide estimates, and we are reporting these annually in both the scientific literature and in the greenhouse gas inventories and in Canada's State of Forest report that are all available publicly online.
Okay, thank you for that. So I'm just kind of wondering, like, we got a report earlier when we had a different, I think this when Beth McNeil was here, and so we have 223 million hectares of managed forest land in Canada, and it's reported that Canada's managed forests sequester 220 tons of carbon per hectare. So when I did the math on that, that's 49 billion tons of sequestered carbon per year. So I'm just wondering, when we're discussing carbon sinks and we're discussing what our emissions are, with numbers like that, I'm just wondering, I think you said earlier our footprint was somewhere around 14. So I'm just wondering where.
18, yeah.
Yeah. So I'm just wondering if we're sequestering on our managed forest land per year 49 billion, so gigatons. So I'm just wondering.
I think there's a profound misunderstanding. First of all, I believe that our Assistant Deputy Minister was referring to carbon stocks, not the annual flux. The fact that the average carbon content of forest ecosystems in Canada is around 220 tons of carbon per hectare means that this carbon has accumulated in some cases over thousands of years in the forest soil and over hundreds of years in the plant biomass. What matters here is not how much carbon is stored, it's how much revenue, how much carbon is removed from the atmosphere. And I think this is the fundamental problem that so many people misunderstand. When we talk about net negative emissions, we talk about the annual rate of removal from the land sector must exceed the emissions from all other sectors combined. So it's not how much carbon is stored in the forest, it's the rate of removal of CO2 from the atmosphere that's the indicator that we must quantify and better understand. We also must understand how we can manage our forests to increase that sink.
Okay, thank you for clarifying that, because I was just running those numbers and just kind of wondering where that was all lining up. So do you have like a data set then on that yearly number that is scrubbed from the atmosphere then that you could table to this committee?
Yes, it is published in the annual State of Forest report. It is published in the National Greenhouse Gas Inventory that Environment Canada compiles and reports the forest sector data since 2016 on an annual basis, and for the period 1990 to the reporting year are all publicly available on the internet. Just Google NIR 2020 and you will get the numbers, or Google for the State of Forest report 2018. The 2020 report will be available shortly if it's not already online.
Thank you, Mr. Kurtz, and thank you, Mr. Patzer.
Thank you.
Okay, Ms. Jones, you are up for 5 minutes, and this will be the last round of questions.
Thank you very much, Mr. Chair, and good morning to all of our guests. I have to say, this is probably one of the most interesting panels we've had since the forestry study started for me, because it speaks about innovation and about the tremendous research and testing that's happening in the industry sector within Canada. I especially want to thank Mr. Kurtz this morning for his presentation and the research that he's doing through natural resources as a scientist in the country. And I think, for many of us, at least for me, I'm hearing a lot of this information for the first time, and I'm excited about it. If I was to pose a question today, I think it would be, as companies in Canada who's really innovating the forest sector and looking at not just new product development, but looking at environmental conservation and all the other measures that go with it. And we're a committee that's doing a study. This study will make recommendations to the Government of Canada and future governments about how forestry should be managed in this country. And not only in terms of management, but what are some of the programs that fit best, that support the industry and allow them to continue to grow and innovate. So that would be my question this morning. What would be your recommendations to us as a committee going forward that you could that you would see most helpful and useful in the work that you're doing in Canada right now?
Is this question directed at me?
It's directed at the full panel, but if you want to take a shot at it first, you go ahead.
Well, first, thank you for the commenting on the work that we're doing. I really appreciate that, and I'm sure my colleagues do too. I'm not here to give particular advice about what government should or should not do, except for one thing, and that is, please rely on the scientific facts when you make your decisions on what is climate effective forest sector recovery. We have the tools, we can deploy these tools. We're working with provinces, territories, multiple US states, European countries, and other countries around the world to deploy these Canadian tools to do these kinds of analyses. The technology is there, the science is there. If you want to make science-based policy decisions, build them on these tools.
So this is Mohini. I would like to comment on that particular last question. In my opinion, we see that there is a fragmented effort. One, we are looking at the bioenergy, we are looking at some of the value-added product, and then you have mass timber. I think mass timber definitely going to take a significant part of our economic recovery. At the same time, I think if you do total life cycle analysis, you will get the type of mitigations of CO2 you're looking. However, having said that, CO2 is everywhere. So therefore, trapping CO2 and using CO2 in a way that a forest industry will be appealing to, that would be one of the, I think, groundbreaking technology. So I would like to propose to the government to promote a concept of biorefinery. So anybody doing a pellets or something, how government can probably look at the investment to transform in the local region, in the northern part where the forests are intensive, where there's biomass, how that convert into total conversion system. I mean, not throwing CO2. If you're really generating CO2, you have to trap it You have to purify it. You have to put it back as a chemical or as a value-added product. So I think if the investment goes in that directions, I think there'll be very good effect. Second thing is carbon credit. It is difficult for industry to compete with the existing petrochemical and plastics and chemical industry. So therefore, anything to start with to give them revenue generations and to grow, I think we need to look at some sort of credit, and I think carbon credit would be one way to go around it, and give the innovation sort of a chance. Otherwise, these innovations will go outside country, and it won't help. And this is what Finland is doing. Some Scandinavians are doing. We have to do it better. We have to do it more effectively and more targeted. And this is my view. Thank you.
Thanks, Ms. Jones. Unfortunately, I'm going to have to stop there because we have to suspend and then we're going into committee business. But I would just like to say thank you to all of our witnesses. The number of our members have said this has been a very informative and very interesting meeting, and that is because of you. So please accept our gratitude and our apologies because we just don't have enough time to go in as long as we would love to do. But we're very grateful for you taking the time to be here. So on that note, we will have to, Mr. Casamini, you have your hand up, I see.
If I may, I just have take 2 minutes of your time. I just wanted to indicate that, following Dr. Cruz, mentioning about using the diseased woods and all the discarded fiber from the forestry and everything, ER's fuel solution is basically on that matter. We do not use, virgin wood or anything else. All we use is discarded wood and discarded fiber that comes from any source of forestry. That's all. Thank you.
Great. Thank you for that. Okay, ladies and gentlemen, we'll suspend. You all have the link to go into our next segment in camera. I will see you all momentarily. And again, thank you to all our witnesses.
Thank you. Have a great day.
You too.
Merci beaucoup.
Thank you.